So looking back at a few videos that you might want to have a look at before we really dive into this one, that are a part of this series about making up your own language and making it work. I did one where you had an executable that we wrote to run it as a CLI program, written in our own language, ran as an executable. And so we wrote an interpreter for that and made that work. We also had one where I made it for the web, to create a web page output. And so integrated that with the web server, created the interpreter, did all what we needed to do to make that happen. Then I made another video that dealt with comparing that versus writing a library to get our advantages taken care of. And I think I made the point that the library is better for those applications. In most of these videos, I am going to be using a lot of PHP and Python. I like to use interpreted languages because it's easier for you to see what I'm doing. I try to explain them well enough that you don't need too much of an understanding of the exact language that I'm working with. But if you haven't gotten those understandings, or if you haven't seen those other videos, I would suggest watching those videos. Now, this is going to deal with compiling your language. And this is where I'm going to kind of make the argument for why you should make your own language. I've kind of argued against it with the libraries versus creating your own language. Now, what's it good for? Other than bragging to your friends, bragging to your professors, your college roommates, bragging to your boss during your job interview, haha, I made my own language. It's probably not good to tease them like that, but still, bragging rights beyond that, what else is your own language good for? Well, here we're going to get into where it can really help you with your production. So if you are a programmer, if you do like to write a bunch of stuff and it's a time-consuming process, you're doing a bunch of web pages, and there's a lot of stuff that you just do over and over again, and just a lot of manual code. That's why computers were made. That's why we learned to program, is so that way we can get that repetitive stuff taken care of. So we're going to talk a little bit about compilers, how they work, and making a compiler, and PHP, which is what I've used for all my interpreters, and I denounced it as a good use as a interpreter to run live because their time matters, so it's better to use a compiled code. But when you're compiling, you're going to compile it when you have time to let it sit and do its thing. So it doesn't matter if you use an interpreted language or not. But PHP is pretty fast anyway, so it's another reason why I love to use it on this channel. It doesn't take up a whole lot of your time to let it sit there, compile, and wait and all that. So, yeah, so can you ever compile your own language? Yes, you can. And we have done this for this video. We're going to have some examples, and we're going to show why it's a good thing to do. So let's first take a look at compilation process. Over on my left over here, I have a typical C-style program. That could be Java, it could be PHP, it could be whatever. But the idea is this is something that would be compiled. And then over here, I did it in assembly form to just kind of give the idea. And you don't need to be all that familiar with even what this language is. This is just a sample. It could be any language, okay? And you don't have to be familiar with assembly. Just an example on how this compilation process works. What does a compiler have to do to turn your stuff into human half-readable code into something that your machine will eat it up? So, machines, they speak binary. They speak machine code. And all of these, you can take a look at my video about how machines think, how do computers think, CompuPsychology, I think I called it, something like that, and get the idea as far as how this equates over into binary as well. But each of these are names of a binary sequence that is a command, a low-level processor command, a single step that processor is going to do in making your program happen. So a typical, typically you're going to start with a source file here, and you're going to tell it to compile. And when it compiles, it's going to take all of this stuff here, and it's going to interpret it into a compiled binary. So in this case here, we've got a function call, and so of course we're going to have a jump saving the return address, and we're jumping to the first parameter is down here. So that's what we do to enter a function. We're jumping to an area that's been designated as that function. The compiler needs to remember which memory address it started writing that function into. And that way, whenever you call it, it can do a JSR to that. Or whatever your language is actually going to do. It may actually have some other way where it creates its own stack and does a JMP, or whatever your architecture actually calls for as far as the actual command as well. But it's going to be whatever equates into a jump saving return address. This is an example of what it would equate to. So we call a function, and we're going to jump saving the return address. That way we can come back after we're done to our next line of code, as a function should do. And it's going to go down here. And then we have set and this memory address, which was assigned. See, it saw that we created a variable, part of that function here. Sure, our function starts here, but the variables are declared up above it in our case. That's what we did on our sample compiler here. So so we ended up setting this. That's what we said. We said set it to true, and so that's what we're going to do. We're going to set them to ones. That's what our case set means. And it sets that address. And now we come down here, and now it's going to say if it's clear, we're going to jump, because what are we doing here? We're entering a while loop. So if this is not true, then we want to jump past it. So it's checking this address, and then we are going to go down to the end of the function, past the function, which means it's restarting. It's jumping back on up to here. I mean, this wasn't all that well. This wasn't very well written as far as assembly. The point was to show how it's going to grab these commands that we enter over here. These are all going to equate to a piece of machine code, and it's going to piece that together, and it's going to have to remember where your variables are stored, where each function is stored, where each object is stored. Now, unfortunately, my latest computer that I actually have any information on the machine code or assembly codes for that we would need to compile our stuff to machine code, the latest system that I have that information for is the Commodore 64. And if you're familiar with those computers from the 70s and 80s, they don't really support screencasts. Maybe someday I'll figure out how to hook up a video recorder and record the output. But right now, Raspberry Pis and Commodores, I just have to explain what I did if I do anything for them. But it's too bad, because that's the only one that I really have machine code for. So we are not going to be able to compile it to machine code. What we are going to do is we're going to compile our own language to another language. And you could even have it to where it compiles it to that language and then starts a compiler there that will compile it down to machine code if you wanted it in machine code. But for my example, I'm using it more for a template generator. But for the basic concept of compilation, we get the idea, I hope, that each of these things over here, they're going to equate to something over here, and they may be variable, so we're going to have to keep track of that. We're going to have to keep track of where this function is, so that way every time we call that function, we go to the right spot. So let's take a look at what we did on here, and I took my web language, and once again we're using PHP, and instead of having it write out like we did on the web page, we're having it output to a file, but we also changed something too. We added an additional command that's going to throw a hiccup in here. So I'm going to explain this real quick too. Most of this was explained on other videos, so I'm not going to spend too much time explaining everything over again. But here we have an additional variable here, and that was something different. Does not need to be a part of this. Alright, that was sometimes whenever you're trying to troubleshoot, you can add something like, say, to dump out a variable and find out why something isn't working. It ended up not being those variables. Anyway, but that's one thing what you can do is dump those variables out and into your program so you can find out why is it acting squirrely whenever it tries to use these variables. Alright, but requires my own library. It requires my library. Normally it won't unless you have a command that requires it, and that's where we can take a look at those code blocks that we include based on our commands or whatever we've done. Is it going to require any additional files? And we can also write those as well. So in this case, maybe it will require additional files, maybe it won't. But this is where we're keeping track of stuff like what resources are open. Because if we are writing a program that's going to open up a resource, we want to make sure we also write in that program to close that resource before it exits. And if it requires libraries, if it's going to use certain features from libraries, we want to make sure that we have the right includes, imports, requires, whatever it be. And we want to make sure that that's taken care of. So we're going to want to make sure we have variables in place to keep track of that. And similar to the web, we did create output string. But in this case, we are opening up the input file, and we don't do the output file until last because we're going to make final edits to it, because this is going to be a decent quality compiler. And so we have our typical grab the command thing that we did all the way down the line, and works for the most part the same way until you get down to our new command, which is the L command, which is similar to P, only we are going to be calling a function that is going to be in our library. And therefore, whenever we call in this L command, whenever it writes this, it's going to make sure that we've set requires my library to be true. So it creates all of this in memory, this entire output file from the file, and then we close that out. You know, we finish up whatever we need to, and then we check to see that we've got everything right. We're going to see if we have, do we require my library? Do we require anything else? Any other imports, includes, requires, whatever they be. And if so, then we're going to make sure that those files are present. We're going to go ahead and output that library where it needs to be. And we are also going to add to my output string at the start of this. We are going to add in the require command to pull in that library. So if we don't require that, if we never use L, then it's clean. We don't call the library, and we don't use that file space. But if we ever do, then it grabs all those things. And there's all kinds of uses for this stuff. And then we're going to output our file as well. We're going to go ahead and send that out to whatever file we wanted to. So what did we do up here? We've actually got two arguments that we're going to use to start this. One of them is the input file, and one of them is the output. And here is our file that we can see. You know, this is our own language that we created. It's identical to what we used in the web version of our language. So Let's take a look at the file system where it is. It's right here, and we have no other files here other than that. Our interpreter is in the bin file directory, and it's marked as an executable. That's where this is. So let's take a look and see what this turns into when we run our compiler. So this is what we called our compiler. It's a PHP marked as executable. That's what we saw the source code from. This is the source file, and this is going to be our output file. It's going to compile it out to PHP. We could compile this thing out to C and have it run the C compiler over our output and have it compile it down to machine code if we wanted to. Not directly, but by calling other programs, we can have all the fun we want to. Because we're programmers. We're eccentric. We can do whatever we want. So we entered that, and yes, very quickly, didn't take much time at all, and we've already got our new file. And here's our output. We do not have a require in here. We have everything that we saw when we output from our last web-based demonstration for this language. But now we're going to spice it up. I'm going to take this last one and I'm going to make that the L command, which means now when I rerun this, yeah, let's go ahead and make that test 2. Now we are going to see that we have a test 2 and a MyLibrary created. So let's take a look at both of these guys. MyLibrary, it has my function in here. MyLibrary function, and it takes its input text, and what is it doing? It's basically HTML encoding it and turning it into uppercase text. Probably if you were going to use your own library, you'd want to do a little bit more to it than that, because that could easily be done inline, especially if you're writing your own language. But hey, it's what we used, and out here we can see it did require in the library, and we also have our function written on here. So this has now been cast into a function that will make all that output as uppercase if we ran this on the server. So what is the use behind this? Why would we want to use this in the real world? And what's easier to do? Writing all of this and all of this every time we want to write out the general gist of this? Or writing this and having something that we can simply type in what we want to, type that out, and now I've got these other two files that I can also make final edits to. Maybe I want to add an additional function on here. Maybe this one's different. You'd probably have a whole pile more commands. But you can use this as a rapid template generator and make it as complex as you want to and make your language whatever you know how to parse. If you know how to use XML, if you know how to use config files, you want to use a tag-based language, whatever you want to, you know, it's up to whatever you can parse. And by running these programs, you can generate this stuff here. And so now if I wanted to change this up, you know, I could add, you know, any other tags I want to and spice this thing up. And this is a bad thing to do, to set your background color to black when your text is by default black. You'll want to make sure that you change your text to something else before you do that. But I'm just making an example that you can change this as you choose, make it what you want, have fun, be productive. Thank you for watching.